Hello everyone, welcome to the Information Theory and Coding classes. In the earlier classes, we discussed about the properties of the entropy. So let us go back once again. So let us brief about what are the things we have discussed in the properties of the entropy. The first thing, the entropy function is a continuous function. So since for every independent variables, that is the probability of emission is it will be varies in the range of 0 to 1. So if there is any variations in the entropy or the probability value, definitely there will be variations in the entropy. So therefore, the entropy is a continuous function which will be always depending upon the probability of emission of the symbol. The second one is the entropy function is a symmetrical function. So since the argument, that is a sum of probability values, is equal to 1, so if there is any variations in one probability value means then the subsequent variations will happen in the another probability values. So therefore the entropy is a symmetrical function. So that is nothing but if I have a two source symbols with a probability value pk, then pk and 1 minus pk, always if you do the calculation in this manner or if you do the calculation in the reverse manner, both the entropy will be same. And the third very important property, as we discussed, that is the extremal property. So you are going to get the maximum entropy from the source symbol when all the source symbols will occur with a equal probability value. Then the maximum entropy will be calculated as it is nothing but log of the number of symbols what you have in a source alphabet. So you will be getting a maximum entropy, and this entropy or this property we call it as a extremal property. And the next one is if you partition the source symbols into sub symbols means then always the entropy will not be a negative value or it will not go to a decreased value. Always the entropy will increases if you partition the source symbol. And the next one is the entropy of the, that is the efficiency of the source symbol, we are going to calculate in terms of eta s, that is nothing but it is a ratio of entropy of the source symbol divided by the maximum entropy of the source symbol. We are going to calculate the source efficiency and the redundancy. And generally, as we discussed, entropy and the source symbols, that is a redundancy, always will be calculated in terms of percentage. Now in this section, let us solve some of the problems which will be asked based upon the source efficiency. Okay. So let us consider this problem, it is PA. So you have a black and white TV picture consisting of 525 lines of picture information. Assume that each line consisting of 525 picture elements, that is pixel, and each element can have a 256 brightness levels. Each element, they said you have a 256 brightness level, and pictures are repeated at the rate of 30 frames per second, and they said that the arrival rate of the frames they said as 30 frames per second. Calculate the average rate of information conveyed by the TV set to a viewer. So this is one of the famous problems which will be asked subsequently in the examination. So let us try to read once again what and all that they have given, and let us try to recollect what we can find the information which is given in the problem, so that we can arrive at the particular entropy information from this problem. So now you can see here a picture consisting of 525 lines of picture information means a TV which has been divided into 525 lines of an element, and assume that each line is consisting of 525 picture elements. So means each element or the each line will be represented in the form of 525 picture elements. So the number of picture elements will be then 525 into 525 elements we will be getting. And they said that each element can have a 256 brightness level. So for one pixel we have a 256 brightness element. For n number of pixels or the total number of elements, it will be the sum of total elements, that is, since they have said it is a black and white TV, so there will be only two brightness level, either it will go black or 1. So therefore it will be in the form of 2 to the power of the total number of pixel elements we need to calculate. So let us try to solve this problem. So now you can see here the TV frame consisting of 225 horizontal lines with each line consisting of 525 pixels. So therefore what we can arrive is the total number of pixels in one frame, which will be 525 into 525. So these many pixel elements will be there, and they said that each pixel can have a 256 different brightness level. Each pixel will have a 256 different brightness levels. So therefore the total number of different frames possible will be 2 to the power of brightness levels. Why we are considering 2? Because it is a black and white TV, only 2 possibilities there. So therefore 2 to the power of 255 into 255 frames you will be getting. Now next, let us assume that all the frames occurs with a equal probability value. Since the probability values they have not given, so therefore we need to assume some probability. So what is the probability we are having is all these pixel element will occur with a equal probability value, that is h max will be, then we can it is easy for us to find out the maximum entropy of the or maximum information which will be conveyed by the source or the TV. So therefore h max is nothing but log of q to the base 2, we can have a calculation. So therefore, so the maximum entropy which is conveyed by the TV, which is given by log of the total number of elements what we have. So we have a 2 to the power of 256 into 256 we have. So if I substitute that, we'll be getting 2,75,625 into log of 256 to the base 2 will be getting. So therefore, we will be getting the maximum entropy 22.05 into 10 power 5 bits per frames will be getting. And they said that the frame rate, that is the arrival of frame rate, will be 30 frames per second. So therefore, the average rate of information will be given as capital RS into small rs into h of s. So the RS they have given it, substitute this, and h of s, that the maximum entropy of the TV we have given it as 22.05 into 10 power 5 bits per frame. If you substitute that, so you'll be getting RS is equal to 30 into 22.05 into 10 power 5, you'll be getting 66.15 into 10 power 5 bits per second. So this is the solution what they have asked for this problem. Okay. Now let us go for one more problem. A discrete source S emits two independent symbols. We have a discrete source which emits two independent symbols, that is x and y, with a probability value 0.05 and 0.45 value respectively. Calculate the efficiency and redundancy of the source they have calculated. So we know that the efficiency formula what we have, it is nothing but h of s divided by h of s max we need to calculate. So first we need to find out what is h of s. So what is h of s? It is the entropy of the source. So since there are only two symbols is there, so therefore summation I is equal to 1 to 2 pi log 1 by pi, we are going to do it. And what are the probabilities value we have? 0.55 and 0.45. So 0.5 into log of 1 by 0.5 plus 0.245 into log of 1 by 0.45. If I substitute that, we'll be getting h of s is equal to 0.9925 bits per symbol we will be getting. And we need to calculate the maximum entropy of the source symbol. And we know that from the properties of extremal property, what is that? You'll be getting the maximum entropy when all the source symbols are equally probable. So therefore, since here we have only two source symbols with equal probable, so what are the source symbols we have? Only two source symbols we have. So therefore, h max is equal to log of q to the base 2. So if I substitute this q value, so you'll be getting 1 bits per symbol. So therefore, source efficiency is nothing but h of s divided by h of s max. If you substitute that, you'll be getting efficiency is equal to 99.258% will be getting. Similarly, the source redundancy is nothing but 1 minus efficiency, which is nothing but 1 minus 0.9928. If you substitute, you'll be getting redundancy is equal to 0.72%. Okay. So this is the solution for the given problem. Now let us go for the extension of the zero memory source. Now what we have, let's say we have some n number of source symbols, and this n number of source symbol we want to extend it, means we want to extend the number of source symbols which is produced by the source alphabet, and that concept we call it as a extension of the zero memory source. So here let us consider we have a, and why it is called as a zero memory source means when I emit a particular symbol, it does not depend upon what is the previous symbol I have emitted, means the arrival rate of the symbols, it is independent of the previous symbols what I have emitted. So therefore it is called as a zero memory source. And since we are extending the number of source symbols which is produced by a particular symbol, so therefore it is called as an extension of zero memory sources. So now let us consider, for the simplicity, a source S, it is having two symbols S1 and S2 with a probability value P1 and P2 respectively. So then, and we also know that the sum of probability of two symbols, or the sum of probability of all the symbols of a particular event, it is 1. So therefore P1 plus P2 is equal to 1. Now the number of symbols what we had is 2. Now we want to extend it. So for the second extension, how many number of symbols we'll be having is, so by using this formula we are going to calculate. What is that? The number of basic source symbols on top of that the extension value. So how many source symbols initially we had? We have a 2 source symbols. And what is the extension you are going? We are going for the second extension. So 2 power 2 is nothing but 4 symbols you'll be getting. See, what are those source symbols you'll be getting? you'll be getting S1 S1, S1 S2, S2 S1, S2 S2 you'll be getting. And what are the probability of occurrence of these symbols is nothing but P1 into P2, P1 P2, P2 P1 and P2 P2. So if I do that, you'll be getting P1 square, P1 P2, P2 P1, P2 square. So therefore, and we also know that the sum of probability of all the source symbols, it should be 0, it should be 1 equal in the extended source also, because the probability has two holds good. So if I do that, P square plus P1 P2 plus P2 P1 plus P2 square, if I do that, so what is this? P1 P2 or P2 P1, what is that? 2 P1 P2, it is nothing but P1 plus P2 whole square, and we know that P1 plus P2 it is 1, so therefore it holds the value, means extension is not affecting any of the probability value. So if I need to calculate the entropy of the second extension, then I need to find out the average information conveyed by these messages I need to calculate. So therefore h of s is nothing but h of 1 by 1 to the 2 pi into log 1 by pi, that is the source entropy of the original source, and the second extension is nothing but I is equal to 1 to 4. Why? Because we have 4 symbols with the probabilities values we have. So if I substitute this, p square log 1 by p1 square plus p1 p2 log 1 by p1 p2 plus p1 p2 log of p1 p2 plus p2 square log 1 by p2 square. So if I substitute that, okay, so since these two symbols are same, so I can add those two symbols, so that is therefore 2p1 square, since this p1 square is there, so I can take it to the numerator, and I can, by using the laws of logarithmic scale, I can take to this side. So therefore 2 into p1 square log 1 by p1 plus 2 p1 p2 log 1 by p1 p2 plus 2 p2 square log 1 by p2. Okay. So now let us try to do what we are going to do is, we are going to divide this log 1 by p1 into p2. We know that log 1 by p1 plus log 1 by p2, what we are going to do, the laws of probability value we are going to list, that is log of mn is nothing but log m plus log n. So that property we are applying, and we are division over here. Okay. So now in this case, now you can see here 2p1 is common in both the cases, so I will be taking 2p1 in this case, and here also I will be taking 2p2 in this case. So if I take that, what you'll be getting, you will be getting p1 log by 1 by p1 plus p2 log 1 by p2 you'll be getting. Similarly, you'll be getting p1 log 1 by p1 plus p2 log 1 by p2 you'll be getting. So if I take both the common, so what you'll be getting is 2 into p1 log 1 by p1 plus p2 log 1 by p2 into p1 plus p2 will be getting. And we know that p1 plus p2 is equal to 1. And what is this? P1 log 1 by p1 plus p2 log 1 by p2. It is the entropy of the first extension, that is nothing but h of s. So if I substitute this, what will you be getting? 2 into h of s into 1. So we'll be getting, therefore, the second extension of the zeroth memory source is nothing but 2 into h of s. Similarly, if I go for the third extension, that is nothing but h of third extension is nothing but 3 into h of s. So in generalization, for the nth extension, I can find it out. The entropy of the nth extension is nothing but n into h of